In this presentation, we are going to be talking about the concept of reliability. A test needs to be both reliable and valid. So let's think about this in very concrete terms. If somebody says to you that you are a reliable friend, what does that mean? Generally, it means that you're consistent, that you come through, that you're there when you're needed, and you're always the same. Being a reliable friend and having a reliable test are very similar. In assessments, reliability indicates when that assessment, that tool, measures something consistently for the same group of people over and over and over again. There are a variety of ways to determine reliability. In this presentation, we're just going to do a brief overview, but as you read your Salkin book, you will be able to go more in depth to understand reliability in a much deeper way. If we're talking about reliability of an assessment, it would consistently produce the same score for that person that they would get on average. So the test is reliable if it consistently produces the same average score on a person time after time after time. Let's talk about a standardized test, and we can talk about MAP, ACT, WKCE, IWAS. Why are these considered reliable tests? One, they have been tested over and over again. There have been statistical analysis of the reliability of the assessment. How do we know they're reliable? It's based on the usage, the results that we get, and if we can consistently get the same results over and over again. What would make a test not reliable? The key concept that we look at is error. So what causes error on a test? For example, on a MAP, a WKCE, an IWA, an ACT. We describe that error mathematically, that the observed score, which is the result that you get, the RIT score, the scale score, whatever number or value that you get, really is your true score and your error score. The less error that there is on a test, the more reliable that test is. The two main types of error on any test are trait error and method error. Trait error resides in the test taker. I'm nervous. I don't like tests. I'm hungry. Something happened at home the morning of the test and I'm upset. I'm distracted. I'm a little ADHD and can't sit for that long. Those are all trait errors. Those reside within the test taker. Method error, on the other hand, resides in the testing situation. It's noisy, it's too cold, it's too hot, there are people walking up and down the hallways. Those reside in the situation or in the environment. Think of some examples of each type of error that you're familiar with. Then think of a major test like the WKC or an IWA. Think of all the ways we try to minimize these types of error. One example for trait errors, we send notes home and we tell mom to make certain her child has a good night's sleep, they've had a good breakfast, that you encourage them, and that you make certain that they are in a good place ready to go before the test. In method error, we make small group settings, we post out in the hallway that testing is going on so that it's quiet. These are all ways that we try to minimize each type of error and then increase the reliability of the results we get on an assessment. Reliability can be calculated mathematically. This slide we're showing just some very, very simple means of how we would do that. The first is that reliability is the true score that a person would get divided by the true score plus the error score, which we call the observed score. Mathematically, we want reliability to trend towards 1. So the smaller the error score is, the closer those results or that reliability will be towards 1. There are many types of reliability, and we're going to talk about 4 very briefly, and your text has greater information on each of these types. But these are the most common forms of reliability that we look at. The first is test-retest. A test or an assessment has test-retest reliability if I will score the same on Tuesday as I would on Wednesday, if I took the test in the morning or in the afternoon, so that if I take it and retake it, I have the same score. Parallel form reliability is when I have multiple forms of a test and they all measure the exact same thing. Think about if you have 2 forms of your test, one for first period and one for 8th period. It's the exact same test and it measures the exact same information, but you've changed it a little bit to avoid cheating from morning to afternoon. These, if they are basically identical tests in substance, though the wording may be different, the order may be different, numbers on a math test may be different, this would be considered 2 parallel forms. The third is what we call internal consistency. This is when we look at the number at each individual item and assure that they measure a single construct or set of constructs. So for example, if you have a math test on measurement, each of the items on the assessment measure the construct of measurement. Or if we're looking at reading and reading comprehension, then each of the items on the assessments measures comprehension. Don't measure vocabulary or fluency. They measure just comprehension. Then you have internal consistency. The last form is what we call inter-rater reliability. This is when you're using a rubric and different people will score the same assessment. If you have inter-rater reliability, then it doesn't matter if person A or person B scores it. You will come up with the exact same or within a reasonable distance, the exact same score. Those measured or marked on this slide by an asterisk are a lot of times used in your classroom. So reliability, while it's critical and important in a large-scale assessment, reliability is also important in your classroom on a day-to-day basis. So what is good reliability? We don't want to look solely at this from a qualitative perspective. We also need to be quantitative. Reliability coefficients are mathematically determined and need to be positive. As we talked earlier, we want to eliminate as much error as possible, so a reliability value is close to 1. Acceptable reliability is if you have calculated it and you have a value of 0.7 or greater. This is acceptable reliability on test-retest, parallel forms, and internal consistency. Excellent, really good reliability is greater than 0.8. On inter-rater reliability, that value should be at least a 0.9. If these levels are not met, then you've got a problem with the test instrument, unless it is a well-known tool that's been used for a very, very long time. Then in that circumstance, you know that it is reliable because of the use over a long period of time. In this day and age, we're looking at that mathematical value to determine if something is or is not reliable.